Hello guys, welcome you all for this end-to-end session on AIML. It's gonna be a year-long program where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying and having fun in learning because like we are enjoying, we are learning a lot each and every day. Hope the same thing for you guys. So this is gonna be a year-long program. So make sure that you guys subscribe to our channel so that you doesn't miss any of our videos. And please press the bell icon so that you will be getting notification whenever we are uploading a new video. So yeah guys, so today's session is all about the coding part of hierarchical clustering. So guys, as always, if you guys are to this video, just make sure that you guys watch all our previous session videos so that you can have a continuation of what we are talking. Okay, because like today is the coding part of hierarchical clustering. If you guys doesn't know about the black box and what is the theoretical concept of hierarchical clustering, then you guys not gonna understand this. Okay, so make sure guys just watch all the session videos and have a proper understanding. If you guys stuck anywhere or if you guys have facing any problem, any challenges, just ping us in the comments. We will take up and we will solve your doubts. Okay, so we are here to do that. Okay, so yeah, without wasting any time, let us jump into today's session. Today's session is all about coding part of hierarchical clustering. So I will give a gist of what is hierarchical clustering, but make sure that you watch all the sessions videos so that you can have an understanding. And last two sessions is all about the theoretical concept and black box of this hierarchical clustering. Okay, so I put it in a simple way. Hierarchical clustering uses the dendrogram to find the number of clusters, and based on that, it will form the clusters. And where it is two types, one is agglomerative and then divisive. Whereas in agglomerative, it is like two takes are the top down approach and then bottom up approach. Agglomerative is top down, bottom up, where we will be starting with similar individual clusters and moving on to the big cluster. Whereas divisive is big cluster to individual clusters. So this is what about hierarchical clustering I am saying a gist of it. For the last two sessions, I think nearly 1.5 hours, we have explained what is the black box of it, how it is working, what are the types of it, what is the linkage, different things. So make sure that you guys watch the last two session videos. Okay. So today we're gonna see the coding part. Okay. Without wasting any time, let us jump into the coding part. Okay. Hierarchical clustering. First thing first, guys. So I hope like now you guys are like memorize these things. Okay. First thing, we're going to import the necessary libraries. First is pandas, which is used to consider the dataset in a form of a table that is called as a data frame. NumPy is used to perform all kind of mathematical operation. Dataset where we're going to import. Today we're going to see a new dataset that is called as a wine dataset. Till now we have discussed about iris dataset, I think so. Today we're going to see a dataset called as wine dataset. It is also pre-built dataset. We're going to import that from the sklearn library datasets. So then we are using standard scaler. It's a, for scaling purpose. That is one of the pre-processing technique that we're gonna use. And then agglomerative clustering. So it is one of the type of hierarchical clustering. We're gonna use that. And then dendrogram. Yeah, we need this. And then linkage. It is from the SciPy library. And clusters import clusters dot hierarchy. We are importing this dendrogram and linkage. Matplotlib. You guys already know, right? Why guys? Why we use matplotlib? Simple, right? Data visualization. Then we are having Seaborn, which is built on top of Matplotlib, which is also used for plotting some graphs. Okay. Then sklearn.metrics, we're gonna import the silver score. That's it. Okay. So these are the important things that we are having for importing necessary libraries in order to perform the following operations. Okay. Next, I'm gonna import the dataset. I'm loading a wine dataset from the sklearn datasets. Dataset dot load wine. So from wine, so because it is a variable name, wine.data, wine.target, x is my input and y is my output, that is target. Okay, so wine, it is the entire data. You can see this is the data. Okay, and these are the targets. We are having 0, 1, 2. Okay, and they are saying it is a class 1, 2 and 3, and there is some instances also, and there are 13 things they are giving attributes. They are having alcohol, malic acid, and then as like those things we are having. Then like the mixture of what they are in the wine. So those things we are having. So yeah, this is all about. So here there are features, right? So like alcohol, malic acid, as so like that magnesium, like those things. Okay, what are the content that are present in the wine? So these are the things that we are having, guys. So hope these are the column names. Okay, so guys, just see here. This is what the x value that we are having. This is our input, and this is a y value that we are having. This is our output. Now, I'm gonna see the shape of this data set. Okay, let's see the shape of x. Okay, you guys just see here. I'm just seeing the shape of it. You guys see 178. This is the number of records, whereas 13 is the number of features that we are having. Next, first five rows. So I'm just passing this yes to the data frame, and for the column we are giving the column name by using the wine variable dot feature names. Okay, that's it. I'm just printing the head of it. Just see here. This is what the top five records that we sorry top five now. It's the first five records that we are having in the data set. Alcohol content, malic acid content, ash content, then something called as a magnesium content, color intensity, hue, like those things we are having for each and every wine type. So we are having three types, right? Zero class, one class, and two class. Based on that, based on these features, we're gonna predict what kind of wine we are having. Okay, whether it is a zeroth class, first class, and third class. Sorry, second class. Now I'm gonna pre-process it. I'm gonna simply apply the standard scalar. So standard scalar, I'm gonna use scalar as a variable. Scalar dot fixed transform of my x, which is my input. I'm gonna give it to the x scale. So when I give this to the data frame of a scale, and then I'm just passing this feature name for the column name, and then printing the top five. You guys just see here, the values are in the range of -1 to 1. Whereas in the previous thing, you guys see propylene, it has the value of 4 digits, whereas wheat and then flavonoids, like those things which has a 1 digit value. That's the thing. As a human perspective itself, this propylene feature is more important because it has a 4 digit value when compared to the other things. Okay, so we will be giving more weightage to this propylene column. So what we need to do means we need to just generalize everything, so that we need to make all the values to some range. Okay, so I'm making all the values to the range of -1 to 1. So that is what we are having here. Okay, so this is everything. It cannot be like definitely -1 to 1, something related to data set. Here I think it's -2 to 2, because like we are having -2 here also, or minus 3 to 3. It purely depends on the data set, but we are standardizing. Okay, instead of 4 digit number in one column and 2 digit number in another column, we are just standardizing. Okay, come, everything should be under -3 to 3, or -9 to 9, -1 to 1, everything in the standard scale. Okay, that is what standardization. Now I'm going to segregate the data set into input and output. Input feature of x scale, that is what we're going to use, and the target variable is y. Since it is a hierarchical clustering and it is unsupervised learning, we need to use this input feature variable, that is x scale, so that we are having. Now I'm going to use a linkage factor. I'm going to pass this x scale, that is my input. I'm just passing this method that is called as var. So var is a way of linkage. So we have seen multiple linkages. Just if you guys doesn't understand, please make sure you watch the previous two sessions where we have expressed you what is linkage that is available in the hierarchical cluster. Linked. Now I'm just passing dendrogram of linked, and it gonna create a plot. Okay, figure size will be 10 cross 7, and title is dendrogram, and it's gonna show. Guys, just see here how many classes that we are having. I'm just asking a simple thing: how many classes we are having? Using the dendrogram itself, we can find. I'm just saying, right? If you guys have watched the K-means coding part, where we will be using something called as a uh, elbow method. That is elbow method. We will be using this kind of method where we will be choosing the number of clusters based on the value at the elbow. Similarly, for this hierarchical clustering, we are using a dendrogram. Based on this, we will fix how many clusters we need. Just see here how many colors are there. Just leave these things out. Okay, we are having 1, 2, 3 clusters. So that should be 3 clusters. That's it. Okay, now we have found 3 clusters. Now I'm going to load the model, that is agglomerative clustering. That is one of the type of hierarchical clustering. I'm just passing the number of clusters to 3. That's it. Okay, so here I'm just fitting and predicting by using this model. So fitting the model, so I'm just fitting and predicting. Okay, so fit predict means it's gonna train as well as it's gonna predict the output. That's it. Okay, I'm gonna fit predict. I'm giving passing the input, that is x scale. Then this is what my entire output. Okay, now I'm going to pass and see the visualization. Okay, so I'm going to give 2 dimension. X scaled is my input. Here also x scaled is my input. Y HC is the value predicted by the model. So I'm saying it take 2 dimension. One is 0th dimension, another one is first dimension, and I'm going to pass all the classes. First time I'm 0 1 2 0 1 2. That's it. So first 0th class will be in red color, and it is considered as a cluster 1. Next it is blue color, and it is considered as cluster 2, and green color, that is considered as cluster 3. That's it. I'm just plotting the graph. We are having title, hierarchical clustering of wine data set, and first feature is the standardized, and the second feature standardized. That's it. If you guys just look into it, you guys can see the flow, right? Simple thing. Red color belongs to one cluster, green color belongs to another cluster, and then blue color belongs to another cluster. So feature 1 standardized, feature 2 standardized. So guys, you can see there is lots of mismatches. Okay, it occurs due to the agglomerative method, and we are using a linkage factor, something called as var. So if we fine tune this, we will be getting very separate and unique clusters which has the data set of their own data points. So consider we are having one cluster here and another cluster somewhere here. Okay, there should be no contact between it, but there is a contact. So it has something called as a error. Okay, but this is a way that you need to do. How to fix it? Based on simple thing. From a matrix, I'm just importing the silver score. I'm giving my input data, that is X scale. I'm giving the model predicted output, that is YHS. And if you see the silver score, it is like 27. Poor guys. But like, this is the flow. You guys need to work on it so that like you guys can increase the training size or test size, and then you guys can use different methods for calculating the linkage, because we have used a word, right? You can use different linkages, or you can go for something like a dendrogram in more depth wise, because like once you tweak the linkage factor, the dendrogram will automatically do, and you can play with number of clusters. Okay, so yeah guys, this is all entire thing that is we are having for this hierarchical clustering coding part. Hope you guys have enjoyed. Okay, we have started with importing the dataset, sorry, importing the libraries. We have ended up with evaluating our dataset. Okay, hope you guys have enjoyed. I have enjoyed a lot, guys. So yeah, I hope like sir is gonna give some more insight on this. Okay, I will just scroll up so sir can take over the session. Yeah, so we have gone to the first level, and yeah, sir, you can continue.
Yeah, guys, if you have come to this session without going to the previous sessions, so it is mandatory and essential to watch and listen and feel and think all the previous sessions 5 to 10 times. So that is a baseline, guys. So I hope you understand baseline. That is the median for learning deeply skills. Okay, that's the standard median, 5 to 10 times reinforce learning so that you deeply understand the concepts, and then we go to the application. So first complete that, then come to this session and give us a feedback on each session, and build a long-term objective function for your career, what you want to become, and become lifelong learner. Okay, don't learn for job and somebody will appreciate or you will say something or you are going to impress anybody. Just learn for the curiosity, learn for knowing things properly so that you can solve big problems and have this bigger vision for you rather than how much salary I'll get, how much, what package, what position I'll get. No, work for a infinite vision, which is like knowing deeply the problems, and that you will know with the data and the concepts, learning deeply them. Then and only you can solve bigger problems, bigger design problems, bigger products problem, bigger application problem, bigger infrastructure problem. There are poverty problem, there are economical problem, okay, and hard problems, okay. So with patience, persistency, consistency, and perseverance, build long-term vision, and press the bell icon and also subscribe to us. We are requesting, but a lot of people, 80% people are not subscribing. I think either we need to improve or you don't like us if you're not subscribing. So I can see the data at backend. So you watch videos, you do all things, you come back, watch, but you're not subscribing. So then you will miss the sessions, no problem. So you will not lose anything if you're going to subscribe and press the bell icon, because then you will get the notification and you will continuously learn. Um, you have to spend lakhs of rupees for such a program and which we are teaching. Okay, so I've seen international prices 30,000 pounds, $40,000 for such a program, and if you don't value it, then we can't help. Okay, so our work is to give value. You have to do your work. So coming to the point of hierarchical clustering, so we know hierarchical clustering, it is it's a very powerful technique, algorithm we use. We have learned about it, and so first of all, as usual, we have to import the libraries, necessary libraries. That's the step one. That is for any project, any model, you have to do that. You have to import libraries. Why? Because, so I'll give a reason why you have to import always. Because computer is dumb. It doesn't know what you want, what you want to do. You have to tell each and everything. And these are individual problem solving libraries which are built for individual for models and different specific, they are doing specific work. So that's why we have to import to build a model, build a project. So these are very important. Okay, so we have to import pandas, numpy, sklearn. Okay, data set we are importing, and then we have to import sklearn dot pre-processing for pre-processing, standard scaler for scaling the doing standard scaling, and then we have to clusters for clustering, importing agglomerative clustering, that because we are doing hierarchical clustering, so we need that library also. Okay, we have to use Dendrogram. Okay, and we have to use Skype dot clustering hierarchy. We have to use matplotlib dot. Okay, we have to use that library, Seaborn, sklearn matrix, Silhouette score, all these. So if they are not there, then we have to code from scratch all these things and then build the model. So that is, so this is 23rd century, or you call it 24th century improvement in programming that we have. Otherwise, each one, guys, it will take months to program each one library. First you have to, then this kind of work will be done. So don't take it lightly that it is just a library. Just understand those concepts properly. Okay, then I'm giving little background today because then you'll have a value. It's not free, guys. It has, scientists have taken years to develop one library. So it's a very hard work, like, guys. Okay, don't take it for granted. So they are very important, and know how to use them. That's very important. Second step is we have to load the data set, which is wine data set. You have to use X and Y variable, target and data set, right? So that you already known till now. If you have watched all the sessions and all the projects, so the outcome is in front of you. You can see wine data set, how Y and X looks like. Okay, let's move on. Yeah, let's go to the step 3, and then you have X array. This is how it looks, the behavior of the data. And then Y, this is how the behavior of the data, 0 0 0 0, then 1 1 1 2 2 2. This is how it looks. And then we go to summarizing. Then we usually do this because we have to summarize the data set. And for that, print shape of the data set, x.shape, print first 5 rows of the data set. Okay, npd.dataframex column wine feature name dot head. You can do tail also, dot tail, and you will get tail, feel of tail and behavior of tail data, how it looks like at tail. But here we are looking at head, how it looks like. So why we do this? We want to see how it looks, and so that we can do better pre-processing, guys. This step is to feel, see, even you can do visualization of the data Are there anomalies? Are there outliers? That's why we do this summary. We want to see it properly so that we can do better pre-processing. That's very important step. So now let's go to pre-processing and pre-processing, okay, of the dataset, standardizing the features. Then we see, so we'll write commands like functions, a scalar dot standard scalar. We want to scale, standardize the features, okay? And then we do it on X and yeah, X scaled, which is equal to scalar dot fit transform X. We have to do transformation, standardization for the features right here. And then we print 5 rows of the scaled data set. So after scaling, then we want to see how it looks like, okay? We have seen summary. So we do the standardization of features, then we see how it looks. Then it is in front of you, the output. Then we go step 5, which is standardization of dataset into input and output based on input features of X scaled, target variable of is which is Y. Since hierarchy clustering is unsupervised learning, guys, that you have to remember, we only use input feature of X scaled, okay? Why we do that? Can you write in the comment section? Okay, so the X scaled array is in front of you. You can see, and you can see and feel and think, both you have to do. I would say feeling data is more important, guys, than thinking, because first comes sensation, then comes feeling, then comes thinking. So feeling generates thinking. So you have to feel the data. And data is everywhere. In your room where you're sitting, the droplets of air is data. The oxygen, amount of oxygen you're having is data. The cells of your body right now breathing, and there are small pores. There is data generated. The energy consumed, whatever food we eat, is data. How much how much food we eat, that's data. Everything is data, guys. Everything, end to end. Whatever you see or feel or whatever exists, whatever you can't see, that is also data. Okay? Other species, other animals have senses which we can't sense. Like dogs can sense earthquake before we, because our senses we don't have. So universe has given intelligence, like if he had 100% intelligence, he has shared intelligence among all species. He has not given intelligence to only human beings. So he has given, like, divided by number of species. Like 100, if 100 is the intelligence scale, so divide by number of species. So that is the spread, that is like it is given. Human beings have more and other species have less. But then if we combine the entire, how much intelligence is given to the entire species, that is super intelligence, guys. The day we tap that, we'll build super intelligence where human beings are not required. They would be managers. Okay, so I'm giving futuristic view. So everything is data. So you have to feel data. Okay, thinking comes second. Then step 6 is visualizing dendrogram. So here again we'll feel the data with visualization. So the linked equal to linkage. Okay, this is okay. Let's go to, yeah, linked equal to linkage x scaled, method equal to what, fit dot figure, figure size equal to 10 7, dendrogram linked, plot dot title, dendrogram plot dot show. This is how it will show. We have to tell and then. Okay. So this is how it looks like. So you can see interconnectedness. Okay. Interconnectedness, then oneness. I can feel that. Interconnectedness and oneness with linkages. Different dendrograms having interconnectedness. Like if you see human genes also, we have four different type of genes, but then there is a combination and permutation. There are millions of genes. So you can see same way there is differentiation, but there is integration. That's why we have calculus, integral and differential. There is continuity, there is discontinuity, right? So integral and differential. Here, integrated, different, but yet integral. Like integrated oneness, but still that's what we call it in normal terms diversity, unity in diversity. So you can feel that kind of thing here, dendrogram, right? So, okay, let's go down. So I'm giving different perspectives. So step 7. So performing hierarchical clustering using agglomerative clustering, creating the hierarchical clustering model. So HC model equal to agglomerative clustering and cluster equal to 3. And then step 8, we are fitting the model. We have to, and YHC equal to HC model fit predict X scaled. So we get YHC here, output array. Okay, guys. So this is how it looks like. Then we go to visualization. We visualize the cluster and we'll do the visualization, and we do plot dot scattered X scaled YHC equal to 0 0, X scaled YHC equal to 0 1, S equal to 100, C equal to red label cluster 1. Same way we do it 2 3. So we have to differentiate yet integrate. Okay, so you will see this duality in everything in life. This duality is the game. Okay, so plot dot title hierarchical cluster of wine data set, plot dot label X label features, you'll see hierarchy cluster of wine dataset 1 2 3, and then this is how it will look like. So why we do visualization? Because we already know, but visualization, human beings are, they understand 80% concepts by visualization. And as a data scientist, if you have to convey this message to an illiterate person or a person who is not a data scientist, who is not a researcher, who is not AI/ML engineer, he also can understand this visualization. That is why it is powerful, because by genetic we are visually paired, okay, and we are textually impaired. So that is why you use more of visuals in your projects, reports, in your communication and making, when you're dealing with clients or when you're communicating. Okay, that's a very, 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 I will say, excellent skill of a data scientist or AIML engineer or researcher. So you have feature 2 standardized, feature 1 standardized, and there are 3 clusters. You can see red. So see guys, why we do clustering? Because clustering is, we have learned this, based on similar features of the data points in the cluster. Okay, so here when we visualize red, we know that this kind of similarity of data sets is spread like this. The blue second cluster, which has different kind of similarity, is spread like this, and then green, which is different kind of. So, oh, I got it. So now this is how my data is spread, and this is how it is behaving. Okay, so it is after standardization, guys. You can do visualization before pre-processing also to compare that how it was before standardization and now how it is after standardization. You can compare the visualization, and this is why this tool, we have matplotlib or or different tools. So use them. If you suppose if you are a fresher data scientist, so use this kind of technique and understand data. If you don't understand other things, use visualization properly so that you can tell, oh, I've trained this model, so this is how the data was when we collected, and this is how when we cleaned it, this is how when I did pre-processing, this is how it looks like when I did standardization, and this is how my model has learned. I'm saying with visualization only you can speak 1,000 words and people will be impressed like anything. Like, this is the hard work you have done. I'm saying even at a stage where you don't know programming or you don't know anything about data science or AIML, you can use this tool very, very efficiently. Okay, let's move to the other. I think we are going deep this session a little. We are going, okay. So step 10, evaluating clustering performance using Silhouette score, and we write SIL slash score, that is for Silhouette score equal to Silhouette score, and slash score x scaled YHC. Then print Silhouette score for three clusters because we have three clusters. Sil, okay, score. Then we get Silhouette score, which is average for three clusters, 27%. Okay, not a problem. You can even have 1%. You can keep iterating, going pre-processing, data cleaning, still not happening. Go and collect new data from the right source and keep doing iteration, and then you get better. Choose the right different model. Try different models. Experiment, okay? But you should know what model you're using. Don't use totally outlier model for your project. Okay. So let's go to the other step.
Yeah, that's it, sir.
That's it, guys. Thanks. We have completed. I think I enjoy, guys. I really love. I feel data. I feel text. I feel all the atoms and molecules of the universe. So, okay. So keep learning deeply at a meta level with long-term vision, with persistence, consistency, perseverance, and patience. Thanks a lot. Let's move to the other section.
Yeah, guys, actually today is a I think today is a depth wise learning, so hope you guys have enjoyed. So as sir is mentioning, we are enjoying and we are learning a lot. So guys, any step, anything doubt to you, just mention in the comment, we will take up and we will solve your doubts. Okay, so today this is all about the coding part of hierarchical clustering. Tomorrow we will look into one more clustering. It's theory and black box, and then we will continue with the coding part of it. So yeah, today all about we are finished with the coding part of hierarchical clustering, guys. So hope you guys have enjoyed. If you guys have any doubts, just ping in the comment section. We will take up and we will solve your doubts. So until next session, guys. Bye, guys. Take care. We'll all meet in the next session. Bye, guys.
Yeah, guys, absorb the information, digest the information, and apply the information. Do all the assignments, mimic this project, imitate this project, and why I'm using mimic. Mimic is an artificial intelligence term. Okay, uh, uh, a model AI is mimicking the human intelligence and the environment uh, as per the objective function. Once we reach general artificial intelligence, we'll have different definition, and when once we reach super intelligence, we'll have different definition. But till now, this is the definition, and actually, I made it my way. This definition, mimicking the human intelligence and the environment intelligence and solving problems. Okay, so you will find different definitions. And mimic and imitate. Imitate is again an AI term. So we imitate, children imitate, learn children's behavior, learn a newborn baby how he mimics and you know, imitates the world and does a lot of reinforced learning. And if you really want to understand machine learning, see the behavior of a newborn baby till 5 years. You will learn a lot, guys. Observe the minute details. You will learn robotics, you will learn machine learning, you will learn AI. Data science, obviously, you have to learn stat and then you have to feel the data around you. But this is how I'll say use different ways of learning. Don't use one way. Okay. Once you observe life deeply at a meta level and the concepts, you become next level, 1% of the world's talent. Okay. So then you enjoy each step. So absorb the information, digest, and apply. Do all the assignments and build long-term objective function and do all the quizzes and comment in the comment section. And if you want, really, we are there to help you guys. You want us to improve these sessions. Please, please, please. I beg you that please give us feedback so that we can continuously improve. That is the only way to go to the next level. So we are saying that please write in the comment section and subscribe to our channel and also press the bell icon. Give us feedback, brutal feedback. If you don't like anything, we will welcome that first, then somebody likes us. So we love positive critique, which helps us to improve. So keep doing that and let's see you in the next session. Thanks.